So welcome. In this new video, I'm going to describe the procedure GRASP, which comes from Greedy Randomized Adaptive Search Procedures. This is a variant of an algorithm that applies the Greedy constructor and afterwards the local search operator. But as I commented in the previous video, the problem of greedy and local search is that the greedy constructor will probably produce always the same solution, or if it in case included some random decision, it is probable that it produces very similar solutions, similar solutions always. So if we apply local search to these solutions, it is very probable that we obtain always the same local optima, and there is not any chance to produce a solution that perhaps could be even better than this local optima. So that's why GRASP comes into the scene. The idea of GRASP is that it applies a randomized greedy constructor. So at the beginning, the solutions are not always the same. Those solutions that are afterwards optimized by the local search procedure. Well, the idea is that as in greedy, these solutions components are selected according to an heuristic function. But here some randomness is introduced. So for instance, let's suppose that the best solution components that you could introduce here are A, B, or C, and the random decision finally takes B. So this is the solution component that has been introduced here. Afterwards, in this occasion, the best solution components might be D, E, A. And somehow you decide, the random decision decides to select A to be written in this position, and so on. So as we have made many random decisions, if we apply this randomized greedy constructor, the solution that we produce and that will afterwards be optimized with the local search will probably be different, or at least more different than in the previous case, when only the best solution component was used. So how do we apply the randomized greedy constructor? I'm using the same problem instance as before, and this is a case of the TSP problem. We have to find a short circuit for this set of points. Let's suppose that we start from city A, and from city A, the heuristic functions tells us to select a new city which is close to city A. So the options, if we consider just 3 cases, the options are B, C, and I. Let's suppose that the random decision takes I. So we make this move. Afterwards, the process is repeated. So which are the closest cities from I? They are B, L, and O. So among these options, let's suppose that the random decision opts to move to CTL. The process is repeated. Let's suppose that between the subsequent options we move to CTP, and after applying this process until we obtain a circuit for this graph, let's suppose that the solution that we obtain is this one. Afterwards we travel to N, afterwards to M, afterwards G, G, H, D, E. You can observe that I'm always choosing one of those solutions which are closest to the current one. One of those solution components which are closest to the current solution component. So as always, we are computing the distances between the current solution component and the other ones which have not been visited. We are selecting the three closest ones, and afterwards I'm making a random decision. So for instance, here from CTA, the closest cities are F, C, and B. So as always, we make a random decision, and let's suppose that we choose F. Afterwards C, afterwards B, afterwards O. Finally, there is only one option, which is Q, and the way back to A. And the solution that we have produced is this one: P, N, M, P, J, G, H, D, E, F, C, B, O, and Q. Well, after this construction phase, we would apply local search with the hope of obtaining a better solution. In this case, the local search applies exactly the same as before, as in the case of greedy and local search. So some edges are removed, others are introduced, and we are always accepting improvements. But the difference between greedy and grasp is that in the case of greedy and local search, the graph was something like this. Now, the randomized greedy is probable to produce more frequently worse solutions. This one. Worse solutions, but different solutions, perhaps even better solutions. So the subsequent local search might end up in worse local optima, or perhaps better local optima. So this way we have been able to sample solutions in this region which are better than those produced by the gradient local search operator. So this is the idea of grasp. In a subsequent video I will explain iterative greedy. So I hope that you have understood the procedure.